All right, here's the first question on GRE Practice Test 1 in the first of the two quantitative reasoning sections, Section 5. It's worth pointing out that this problem and the 9 that follow it are all of the same type, where you're comparing two different quantities. Definitely make sure you read through this on your own time. You don't want to be wasting any of the valuable test time understanding what they're asking you to do. Up here are some instructions and assumptions. Nothing super important in here, but definitely worth reading through at some point. And then down here are the instructions specific to these first 9 questions that essentially say they're going to give you two things, and you figure out if the first one's bigger, the second one's bigger, the two of them are the same, or this fourth option, which really confuses people. Essentially, we can't tell which one is bigger from the information that's given in the problem. Anyways, question 1. The two quantities that we're supposed to compare, figuring out which one is bigger, or if they're the same, or if you can't tell which one is bigger, is this length x in this picture and the number 5. I think the key realization of this problem is recognizing that you can make two right triangles in the image, one here and another one down here. If we start with this triangle down on the bottom, because it's a right triangle, anytime you know the lengths of two sides of the triangle, you really know the lengths of all three sides of the triangle using this thing called the Pythagorean theorem. Obviously, you don't have to remember that it's called the Pythagorean theorem. You might know it as that a squared plus b squared equals c squared thing, where a and b represent the length of the legs of the right triangle, the two sides that touch the right angle, and c represents the length of the hypotenuse, the side opposite the right angle. So in this triangle down here, a and b are 3 and 4. It does not matter which one is which. And if I call the hypotenuse, I don't know, c maybe, I know that 3 squared plus 4 squared equals c squared. So 9 plus 16 is c squared. So 25 is c squared. So c must be equal to 5. It's worth pointing out that while you can solve for the length of the hypotenuse this way, you could save yourself a lot of valuable test time by just memorizing that a 3, 4, 5 right triangle is a thing. In fact, it's probably the most common right triangle that you'll see on any test. Less common, but maybe worth memorizing, are multiples of these numbers. So like if I multiply all these by 2, I get 6, 8, 10, and that will also be a right triangle. You can try it out. This squared plus this squared equals this squared. Similarly, multiplying by 3 would give me 9, 12, 15, 30, 40, 50, whatever. Any multiple of 3, 4, 5 will always give you the length of the sides in a right triangle. They're called Pythagorean triples. Those aren't the only Pythagorean triples, but they're the smallest whole number sides that create a right triangle, so they're really common on tests. The other one where the numbers are relatively small is 5, 12, 13. And again, you can use any multiple of 5, 12, 13, so 10, 24, 26, for example. But these are far less common. I think 3, 4, 5 will be most of the ones you'd see on your test. There's lots of others, but I'd be shocked if you ever saw anything other than the 3 that are listed here. Anyways, if you had memorized that 3, 4, 5 was a Pythagorean triple, you'd immediately know that c was equal to 5 and wouldn't have to do this work over here. And once you know that c is 5, you can get a little bit clever and recognize that this side length here must also be 5. And that's because O is the center of the circle, so the length in green must be the same as the length in brown or whatever this is. Each length is the radius of this circle, so they gotta be the same number. Then maybe you realize that, hey, wait a minute, I have two sides of this right triangle right here. And a minute ago, you told me that anytime I know two sides of a right triangle, I really know all 3. Yup. You can just use Pythagorean theorem again, but be a little bit careful. The 3 and the 5 are not the A and the B. The 5 must be the C in this equation because the 5 is the hypotenuse of this right triangle. So I could, again, use the Pythagorean theorem where A and B are 3 and x respectively. And as I already mentioned, the c is equal to 5. So I got 3 squared plus x squared is equal to 5 squared. And then I just solved this equation for x. 3 squared is 9. 5 squared is 25. If I subtract 9 from both sides of the equation, I got x squared equals 16. Taking the square root of both sides, I got x equals 4. Technically, I should get a plus or minus 4, but because we're talking about side lengths here, I only consider the positive solution. Now that we know that x equals 4, since 5 is bigger than 4, I mark b over here because quantity b is bigger than quantity a. Again, in the interest of saving time, I could have cut out all this work right here. When I'm staring at this right triangle here, and I know that one of the sides is 3 and the hypotenuse is 5, I know that I have a 3, 4, 5 right triangle. I immediately know that the other side length must be equal to 4. I don't have to do this algebra down here. If there's two things you really want to take from this problem, it's recognizing that 3, 4, 5 right triangles are a very common geometric shape when you're looking at standardized tests, and that this relationship between the lengths of the sides of a right triangle, the Pythagorean theorem, is really, really useful. I probably should call this video good here. I think this is the method that the test takers had in mind for how you solve this problem. But I do want to show you a couple clever shortcuts that, even though you probably wouldn't think to do them this first time you're solving this problem, might be worth seeing just in case you ever see a very similar problem and can save yourself a little bit of time. The first one comes down to a key fact about right triangles. It's that the hypotenuse is always the longest of the three sides. I'm not going to prove that to you, but maybe you can talk yourself into it just by looking at a right triangle or by thinking about this Pythagorean theorem and how we're adding together these lengths on this side, and therefore C has to be bigger than either A or B. Whatever, this is true. The hypotenuse is always the longest of the three sides. So when we were solving this problem, after we figured out that this hypotenuse right here was 5, we immediately knew that x must be less than 5 without even having to solve for what x is equal to. Because 5 is the exact value of quantity b here, we know the answer to the question before we even figure out that this is 4. This fact tells us that x must be less than 5. You don't even have to solve to figure out that it's equal to 4 to know that quantity A is less than quantity B, and therefore B is the correct answer. All right, that's not that cool, but I have a better trick to show you. If you were really clever when you stared at this diagram, you might notice that these two triangles are actually the exact same triangle. They're what are called congruent. It's a little bit hard to see, I think intentionally so, the way it's drawn, but maybe if I redraw things over here, it'll be easier for you to tell. So we got this top left triangle, and what we're given is that the two side lengths are 3 and x respectively. Later we figured out that the length of the hypotenuse was 5, but pretend we hadn't even done that work yet. Then you got this triangle down here, and given is that the length of the two legs are 3 and 4 respectively. Again, we later figured out the length of the hypotenuse, but pretend we didn't do any of that yet. If you take this top left triangle and rotate it so that the right angle is down in the bottom right corner, then this side over here with length 3 would be over on this side, and this side with length x would be down here. And then maybe you could stare at these two triangles and recognize that the green one is the exact same as the kind of dark red one if it's reflected over this line. Because they're the exact same triangle, x must be equal to 4, so we know that quantity b is bigger than quantity a without doing any Pythagorean theorem or any calculations at all. Unfortunately, that relies on recognizing that the two triangles are congruent, which I think is asking a lot of a student that's taking this test. But since it's such a slick way of solving this problem, I figured it was worth mentioning.